Okay, tin 2 chloride, SnCl2 can exist in the molecular form. Okay, so first thing about this question, right? Sometimes when students see a metal with a non-metal, straight away they jump to the conclusion that this one must be ionic. Might not be, because this question they actually tell you upfront that it is in the molecular form. So literally they are telling you it is a simple molecular structure. Okay, it's a simple molecular structure. So in the gas phase, it exists as anhydrous SnCl2. Anhydrous means no water. There's no water. Okay, in the solid phase, right, it can exist in the molecular dihydride form. Molecular dihydride form. Okay, so this molecular dihydride form, it means that there's two molecules of water attached to tin chloride, tin 2 chloride. How does the water attach to it? Don't know yet, but we're going to work it out. Okay, it has a low melting point of 38 degrees Celsius. It has been observed that one of the water molecule directly bonded to the tin atom, forming an addition product. The other water molecule, however, is not directly bonded to tin chloride molecule. Which means what? There's two molecules of water. One is bonded directly to tin, the other is not. Okay, the other probably is bonded via hydrogen bonding to the water molecule. Okay, because if you're not bonded to tin chloride, then you must be bonded to the water, right? If you're not bonded to the water, then why is there two molecules of water? Okay, so definitely the water is bonded to the other molecule that is already bonded to tin chloride. Okay, so how do we draw a dot and cross for gaseous? So gaseous, it is just by itself. It does not have water. Okay, it does not have water. Okay, so just to emphasize, the question said the gaseous form does not have water. Okay, so we draw the gaseous form first. Let's draw tin, Sn, and then we have tin have 4 valence, 4 valence. So single bond to chloride. So chloride has 7 valence. Let's just put it down like that. Daniel, this one not paper lah. This one is like a past long time ago my school the quiz, right? So I just take it for practice lah. Okay, because my students say that they need some practice on chem bonding, so I just use some past test quiz paper and then just do some practice lah. Okay, definitely this has nothing to do with PSLE science, too far away. Okay, so wait, where was I? Tin still has 2 more, right? 2 more, 1, 2. So you can see the dot and cross, right? It looks like the tin is not octet configuration, right? So it's still lacking like 2 electrons to get to like 8 octet configuration. So this tin, right? Do take note, as of now, this structure, the tin is electron deficient. Okay, tin is electron deficient. Okay, so dot and cross easy, right? Tin chloride. Okay, using VSEPR theory, deduce the shape. Okay, so this is our favorite, right? This is one of the easiest things to go through. Okay, so first thing, you tell the examiner how many bond pair, how many lone pair around the central atom. Okay, so how many bond pair? You can see from the dot and cross. Quite obviously, there is 2 bond pair and there's 1 lone pair around tin atom. Okay, so to minimize repulsion, maximize stability, these 3 electron pair directed to corners of what? You all must memorize this, directed to corners of equilateral triangle. Okay, equilateral triangle. The other shapes we also must remember, right? According to VSEPR, 4 electron pair is tetrahedron. 4 electron pair, tetrahedron. 5 electron pair is trigonal bipyramidal. Okay, 6 electron pair is octahedron. Okay, all these basic shapes you all must remember, yeah? Okay, let me just highlight, 2 bond pair, 1 lone pair around central atom. Okay, central atom. To minimize repulsion, maximize stability, standard phrasing. 3 electron pairs, your 3 electron pair directed to corners of a equilateral triangle. Okay, please take note of the spelling, take note of the spelling, especially for tetrahedron. It ends with a RON, tetrahedron. Okay, so whenever you have lone pair, right? VSEPR theory. So whenever you have lone pair, right, you have to bring in this statement: lone pair bond pair greater than bond pair repulsion. All right. So here we only have 1 lone pair, so we don't need to talk about lone pair repulsion. So we just need to bring in lone pair bond pair greater than bond pair. Praxion, I don't really teach one-to-one. I taught Olympiad in secondary school before, Catholic High, but I don't really teach one-to-one now. But if you want, please contact me. You can text me on my work number. Yeah, you can find the number, I think, in my bio. Website is also there. So you just drop me a WhatsApp first. I'll reply you later. Wow, nice lah. Talk about H2 Chem, I appear. That's me, Mr. Chemistry. Nice. Okay. What days do you do live? Hey, actually, today is the first day I do live. Yeah, first day. So I'm not sure whether can you all hear me properly, see me properly. Okay, please let me know if it is all okay. I will try to do it like every Sunday night because other days at night are pretty busy. I have classes also. Yeah, anything if it's not clear or whatnot, please let me know. Okay. Chem Olympiad quite confused. Yeah. I think Olympiad sometimes is a little bit difficult. Very clear sound. Thanks so much. Wow, I use this mic. I think it's a good investment. Oh no, Praxion, why strong acid and weak conjugate base? I can reply you, but is it okay that we wait for another day? Because today I want to focus on chem bonding. Okay, and I think some of my students, they want to know about chem bonding because WA coming up, chem bonding. Okay, so if you all know any friends who have any WA or chem bonding coming up, please direct them to this live. Okay, I won't be doing this for too long. Okay, just quickly ask them to come in. Okay, help me to like and share. Thank you so much. Okay, so back to the tin chloride. So after we put in the extent of repulsion, lone pair, bond pair greater than bond pair, then we say the shape, the actual shape. Okay, so this will be the actual shape. Actual shape. Okay, actual shape, right? Remember, taking into account the lone pair. Okay, so actual shape, you take lone pair into account. Okay, so basic shape is trigonal planar, then actual shape, remove the lone pair. Okay, so that's it for explanation of VSEPR. I think pretty straightforward.